Hello and welcome to lesson 2 of week 9. We're going to add and subtract radicals today. If you can understand what I'm about to show you here, this lesson can be pretty easy. Okay, so we're going to add and subtract like term radicals and express the answer in simplest radical form. So we're going to take a peek at some stuff here. Adding and subtracting radicals. A lot of people think, oh, the square root of 7 plus the square root of 5, that must be the square root of 12. Well, take a calculator and try that. Do the square root of 7 plus the square root of 5. Hit enter. You should get 4.881819 and so on. Now take the square root of 12 and type it in your calculator. If you do, you should get 3.46410 and so on. Those are not equal, which means the square root of 7 plus the square root of 5 is not the same as the square root of 12. You cannot add those together. To add or subtract radicals, you must combine like terms. What makes a like term? The radicands must be the same. The number under the radical must be the same. So I'm going to connect to what we've already done. So we did this type of problem several weeks ago. To subtract these polynomials, we needed to combine like terms. So we would switch the subtraction to plus, and we changed the sign of all the terms in the second polynomial. So the negative 6x to the third became positive 6x to the third. 9x squared became negative 9x squared. Negative 11x became 11x. And we added those together, and when we did, look what happens. I get 9x to the third. The 3 and the 6 add to get 9. X to the third didn't change. 7x squared and negative 9x squared made negative 2x squared. Negative 4x plus 11x made 7x. We're going to do almost the exact same thing with radicals. So what I need to do is I'm going to add or subtract like terms. So what are like terms? Well, the square root of 7 goes with 8 radical 7. Now the number in front of the radical 7 is a 1. 1 plus 8 is 9. Radical 7 doesn't change. I don't change the radicand at all. Move on to the next radicand, so 5. So 1 square root of 5, or just square root of 5, plus 2 radical 5 is 3 radical 5. Move on to the next one, radical 3's. 4 radical 3 plus 2 radical 3 makes 6 radical 3. I can't add those together any further. I'm done. Try this one. You might say, well, can't do anything. A lot of people do. Don't do that. You got to make sure you simplify everything that you can. Well, 4 radical 2, I can't do anything to. But 18, I can. So the 5's already on the outside. Square root of 18, I can say 9 times 2. Well, the square root of 9 is 3. So now 5 multiplies by 3 with the radical 2 left over. That gives me 15 radical 2. So 5 square root of 18 is the same as 15 square root of 2. Now that I've done that, the numbers under the radical, or the radicand, are the same. We have like terms. So now I just subtract 4 minus 15 and get negative 11 radical 2. Let's try a more difficult one here. So 6 radical 12 plus 8 radical 48. The 6 on the outside stays the 6 on the outside. Square root of 12 is 4 times 3. I highlight the 4 because the square root of 4 is a good number. 8 on the outside again. The square root of 48 is 16 times 3. Again, I highlight the 16 because the square root of 16 is a good number. So square root of 4 is 2. The square root of 3 stays the square root of 3. 8 times the square root of 16 is 4. Square root of 3 stays into the radical. Now I can multiply 6 times 2 and get 12. 8 times 4 and get 32. They both have 3's under the radical, so I could add 12 and 32 together to get 44 radical 3. So as long as the numbers under the radical are the same, you can add the numbers in front or subtract if it's subtraction. If they're not the same, you can't put them together. That's the big idea from this lesson. And that concludes lesson 2.